Hey guys, so welcome back. In the previous video, we created our lottery Solidity smart contract. Alright, so before going any further, I would like to clear the doubt about what are pure functions inside Solidity. Alright, because you see them very rarely, and actually inbox.sol was a great example of that. Alright, so I have my inbox.sol opened right here, and as you can see, I have function do math, which is public and pure. Alright, so pure functions are actually the functions which neither alter any data inside the smart contract, nor do they return already stored data inside the smart contract. Alright, so as you can see, we have a contract state variable over here which is called message. Now the thing is that neither does our do math function alter message, but also it does not return message. Alright, so if you look at the previous functions that we created, that is set message, that alters the message variable, and if we look at get message, which is returning the message variable. All right, and these two functions cannot be defined as pure because they are interacting with the state variable of the contract. Now if we look at the do math function, it is simply taking two variables, it is adding them, subtracting them, multiplying them, and checking its equality. Now it is not returning any contract state, neither it's altering one. So functions like these are known as pure functions. All right, so now that I've got this out of my system, now let's get back to lottery.sol. Alright, so I am back inside my lottery.sol, and today we are actually going to attach a front end to this contract. Now the thing is that I have already attached a front end to this. So the one thing that I found missing in this contract while developing a front end was that I wasn't actually displaying, or we didn't have any function that could return the current lottery pool. So we are actually keeping track of manager, we are actually keeping track of all the players that are inside our lottery. But the thing is that nowhere in our smart contract are we returning the lottery pool. So what I have done is that created a new function at the end of our contract, which is called function lottery pool. Alright, which will return the total lottery pool, which is currently inside our lottery. Alright, because anybody who wants to enter a lottery, I mean, what's the catch for him? Alright, what makes him enter the lottery? Alright, that's the lottery pool. I mean, higher the lottery pool, the higher the chance it is that one would actually decide to enter a lottery in the first place. Alright, so what I've done is that we are simply returning address this.balance. Alright, now as you guys know, this is referring to the instance of this contract. Alright, and we are actually converting this to an address. So this will be actually the address of the contract where all the cryptocurrency is getting stored when one enters our lottery. And all of this cryptocurrency gets stored at the address of our smart contract. Alright, so we are accessing this address and then accessing its balance property, that how much balance our smart contract contains, and simply returning it. And this would return the lottery pool for us. So now I won't be testing this smart contract inside of Remix, so I would directly be going and deploying it onto the Sepolia test network and connect it to my React frontend. So what I want you guys to do also is to deploy your own lottery smart contract. Alright, and I hope you remember all the steps: setting the environment as the injected provider MetaMask, alright, which will open up your MetaMask for you, and you can connect your MetaMask account to Remix. And once your account is actually connected, your account would actually show up with the amount of ether that you have inside your account. Alright, and obviously then you would select the lottery contract in the contract selector, so the contract that you want to deploy, and obviously hit deploy. Alright, and this will again open the MetaMask for you, and you just need to confirm that transaction. Alright, make sure you have enough cryptocurrency in your account in order to pay the gas fees. So once that contract gets deployed, what I want you to do is go into your activity tab inside MetaMask. Alright, check the contract deployment activity, click on it, and click on the view block explorer. This will take you to Etherscan. Alright, and from there you can actually grab your created contract address. Alright, and I want you to keep it safe with you somewhere, or you could always access it again on Etherscan. So for me, I have already deployed my own smart contract and I already have its own address. Alright, so now I have created a basic React template, assuming that you guys already have a basic understanding of React. Alright, and even if you don't have a basic understanding of React, this video is actually going to primarily focus on connecting a smart contract to a JS application. Alright, in general. Alright, whether you know React or not. So this is going to be a tutorial for Ethers.js. Alright, this is a node library for connecting smart contracts to your JS applications. or should I say node applications. So the library name is Ethers.js. Okay, you can go ahead and Google search that and also read its own documentation. And for both, I will provide a link down in the description. So what I want you guys to do is actually create your own npm project or create your own React project. Alright, for that you could actually run npx create React app inside your folder. So once you are ready with some kind of a starter template or a simple node project, so what you can do is go ahead and install Ethers inside your node project. Alright. Now, I want you to install a specific version of Ethers. Alright. The thing is that version 6 is currently out and it's in beta testing. And if you actually hit npm i ethers, it's going to install version 6 for you. The thing is that on version 6, some of the functionality is currently broken because it's in beta testing. Alright. So what I want you guys to do is install a below version 6, that is version 5. Alright. So I would be working with version 5.7.2. And if you guys also want to be on the same version as me, so you can actually hit npm i ethers at the rate 5.7.2, and this will install this specific version for this Ethers module for your node application. So go ahead, hit enter and install Ethers.js into your node project. Alright, so now I have installed Ethers.js in my own node application or my own React application. You can also go ahead and check the package.json if the Ethers module is correctly installed with the correct version. Alright, so for me, the Ethers is currently installed with 5.7.2. Alright, so I'm going to zoom pass through some React stuff, but I will be explaining all the Ethers stuff in detail. So there is something called use effect which runs every time when a component gets mounted onto the DOM. So the thing is that we would actually be calling all our data from our contract inside this use effect. So before displaying any data onto our screen, we would have all the data from our smart contract. Alright. So before we do that, we actually need to know whether the user has MetaMask extension installed or not. So what we want to do is that we want to check this by writing if window.ethereum. Alright, so this is a global API that is injected by MetaMask so that web applications can actually detect accounts inside of MetaMask. Alright, so if this actually returns true, that means that the user has the MetaMask extension, otherwise they don't. Alright, so and we would obviously be displaying some message accordingly to that. Alright. So if they have MetaMask, so what we want to do is that first things first, we want to pull their account. So we want the current address that is currently logged into the MetaMask account. So in order to do that, we are first going to grab a Web3 provider that is provided by MetaMask. Alright, so we are actually going to call this provider. Alright, so const provider is equals to new ethers.providers.web3 provider. And then we are going to pass in the two parameters of the Web3 provider, that is window.ethereum and any. So what happens here is that MetaMask injects a Web3.current provider, alright, in every web application when it gets installed as an extension. Alright, so we want to grab that current provider because it contains all the current accounts attached with MetaMask and all the cryptocurrency and the signer data. So we are actually going to use an Ethers.js Web3 provider wrap-up and actually grab that provider for ourselves. So this provider is nothing but the MetaMask provider with all the accounts of the current user that's logged in. And the next step is going to be grabbing all the accounts inside this provider. Alright, so we would actually write provider.send Ethereum underscore request accounts, and then we would pass an empty array. These are the parameters that are actually required by the send function that we can chain over the provider. Alright, and this will actually give us all the accounts inside of our provider, inside of an array. Alright, so this would be an array of addresses. So provider.send actually returns us a promise. Alright, and we can grab that promise by .send and .catch. Alright, so what we can do is that in .then we can actually grab the response that would be received when the provider.send actually completes its execution. Alright, and actually returns us an array of addresses. Alright. So we would actually grab the signer response, that is the response that would be given us by the provider.send. And what we will do is that we will actually grab the address of our current logged in account. Alright. And as this is going to be an array of addresses, we actually want the first index of this array. Alright, because this would be actually the account that you are currently logged in with. So this signer response is actually going to be an array of addresses. Alright, and in line number 22, as you can see, I've grabbed the signer res and index 0. That means I've grabbed the first address inside of that array of addresses. And I've actually set that address as my address state variable inside my app.js. Alright, and the second thing that we are actually going to do is actually create a signer. Alright, Now, a signer is actually going to be required every time when you actually perform some applications on the blockchain. I mean, when you are calling the functions on your contract, which actually performs some operations on the blockchain, are actually always going to require a signer, all right? Because they want the signer who is going to pay for that gas. All right, so you can actually get that signer by simply calling provider.getSigner, and this will give you the current signer for the current logged in account. You can also verify this signer response at index 0 by just simply console logging it here. All right, so now we are actually grabbing our current MetaMask logged in account. So now the next step would be to create a front-end Solidity contract instance. So now this is the main thing for which we actually installed our Ethers.js module in the first place. So now we will write const contract is equals to new ethers.contract. So with dot contract function chaining onto your ethers object, you can actually create a front end contract instance. All right. But the thing is that you actually need 3 parameters for this. So the first thing that you need is actually the contract address on the blockchain. All right. So this is actually the contract address which I received once I deployed my lottery contract. All right. And you can actually replace this with your own contract address. All right. The next thing that we want is actually the ABI of the contract. And the third thing that we want is the provider that we just created above. So this provider is actually going to be the current logged in MetaMask provider. So currently we actually have 2 of these parameters ready with us. So one is the address, which you will get once you deploy your contract on the Sepolia test network, and you can actually grab that from the Etherscan. And obviously we have already created our provider. So the last thing that we want is the ABI of the contract. All right. So this we can actually grab from Remix. But before grabbing the actual ABI, what I want you to do is that create a new folder inside your SRC named ABI. And inside that folder, I want you to create a script named config.js. All right. And this config is actually going to contain your contract ABI. So what I want you to do in here is actually create a constant variable ABI and then export it from the script. So you will actually write module.exports is equals to ABI. So now the only thing that we want is the actual assignment to this constant variable ABI. So I'm back into my Remix and I'm actually in my Solidity compiler tab. And you actually want your lottery contract to be selected down here in the contract input field. All right. And what I want you to do is actually hit compile, or if you already have it auto compiled, that's well and good. So what I want you to do is that actually copy the ABI from here. So copy ABI to clipboard. All right, click on that. So this will copy the contract ABI for you and then simply paste it as assignment to the constant variable ABI. So here, as you can see, I have pasted my contract ABI as an assignment to my constant variable ABI. So as you can see, the whole ABI is here, and then ultimately we are actually exporting this ABI constant variable. All right. So obviously now that we have exported this constant variable, we also want to import it inside our app.js. So once you have imported your ABI into the app.js, Ethers.js is now actually going to create a front-end instance for your contract. All right. So this ABI is actually needed for a contract to actually interact with the third-party languages. All right. So something out of Solidity, all right, like JS. So if you want to interact your Solidity contract onto the front end, you actually need the ABI. And if you actually go ahead and look closely onto an ABI of a smart contract, you would actually notice that it actually describes each and every function that is inside your smart contract and what parameters it's receiving and what it's going to return. So it's actually more or less like an object representation of a smart contract. So with which you can actually create a same instance of that contract onto a different language. All right, so for us, it's going to be JS. So now if you go ahead and console log the contract variable and go ahead and look onto the console, you could actually see your whole contract. So now as you can see, I have assigned that contract also as the state variable of my app.js. And this I would actually use in the future. All right. So for now, what we want to do is that in the use effect, we actually want all the data that's currently stored into our smart contract. So we want the manager of the smart contract. We want the players that are currently participating into a lottery. And we also want the total amount pool that's inside a smart contract. All right. So we are actually going to access it by chaining some function calls. All right. So the thing is that each time you call a contract function, it's actually going to be similar to calling an API. So if you have some experience in handling APIs, this would be just a walk in the park for you. So this is nothing but handling some promises, or if you don't like promises, you can actually handle it by async and await. So previously we are already handling a promise in here, which is actually returned by .send from our provider. All right. So once we get a response from our provider, that is we have an account to interact with, after that we want to interact with our contract. So I'm actually going to chain all of my contract methods inside the dot then of my promise.send. All right. So the first thing that we want is the manager of the contract. All right. So we are actually going to call contract, that is contract.manager. All right. Now this is the actual function name that's inside our smart contract. So if you go ahead and look onto our contract, we actually have a public variable known as manager. And as told before, every public variable is actually a function. All right. So we can actually call manager directly by saying contract.manager. And obviously every function call is going to return a promise, and it's your choice to handle it by .then or .catch or just by simply async and await. So I actually like handling my promises with .then, so I would actually chain .then onto this and actually wait for the response. All right, so I have currently renamed the response here as admin. All right, so admin of the contract. All right, and then once I receive this response, I'm actually going to set it as a state variable inside my app.js. All right, so I would actually be storing the address of the manager of this contract inside a state of my app.js. So once we receive the manager of the contract, after that, inside of the dot then I would chain all the players. All right, so we would write contract.get players. All right, and this would actually call the function get players inside a Solidity smart contract. And in the same way, I would chain a dot then and grab the response. For here, I have renamed it as list and also assign it as state inside my app.js. So now we have manager as well as all the players in our lottery. And the third thing that we want is the amount pool. All right, so the total amount pool that is in our lottery. So we would actually call contract.lottery pool. So this will call the lottery pool function inside our smart contract. Similarly, we'll chain a dot then, rename the response as the amount, and set it as a state variable inside the app.js. Alright, so now what we have is that we have all the data that we can grab from our smart contract. Alright, so we are grabbing the manager of the smart contract, we are grabbing all the players that are currently in our smart contract, and we are grabbing the total amount pool that's currently in our lottery. So now that we have grabbed all the data from a smart contract, we are actually now ready to display all this data onto a front end. So now I'm going to attach a very minimalistic JSX and actually see all this data onto a front end. Alright, so this is how the front end is going to look like. Alright, so up here is going to be the current logged in MetaMask address. So for you, this would be actually your MetaMask account address. Alright, so this is my account address and I'm actually seeing it up here because I'm grabbing my instance or I am grabbing my own provider. Alright, so for you, you would be actually grabbing your own provider. Alright, so and then we are actually displaying the lottery pool, which is actually currently 0 ETH. Alright. And then we are actually having an input field where you can actually write the amount with which you want to enter the lottery. All right. And then obviously 3 buttons: enter the lottery, pick a winner, and pick winner is the button which is only going to be available for the campaign manager. And the third one is actually going to be show players. So if you actually click on show players, currently there are no players to be shown up here. So you could just simply go back and actually enter the lottery in order to be visible in the show players. So now let's get back into the application and actually attach some functionality to enter the lottery and actually pick a winner from the lottery. Alright, so in here I have created a function that's going to handle entering the lottery. Alright, so I have named it as handle enter. Alright, and it's going to be a JS arrow function and it's actually going to handle what's going to happen when we click the enter lottery button. So as I told you before, if you call a function and it's going to cost you some gas, you actually need to provide a signer for it. Alright, and that's why we grabbed the signer in our use effect. So in Ethers.js, you actually need to create a contract, which we also created in our use effect. But the thing is that in order to provide a signer for it, you actually need to connect a signer to that contract. Alright, and that's what we are doing in the first line of this function. All right, so we are creating a new variable, lottery contract signer, and we actually have our contract that is lottery contract, which is actually a state variable, which I have set as a state of my contract that I've created in the use effect. All right, and onto that I am chaining .connect, which is a Ethers.js function which you can chain onto a contract and actually add a signer to it. All right, and this is also a state variable that we created in our use effect. So this is the actual signer that we grabbed inside our provider.send. All right. So now this contract is actually signed, and that's why I have named it as lottery contract signer. And then with this signed contract, you can actually call the enter function that we created in our smart contract. So we are actually going to write lottery contract signer dot enter, which is the actual function inside our smart contract. And this is how you actually pass a value. All right. So when you are interacting with cryptocurrency or you want to send some cryptocurrency, so this is how you pass the value. So you create an object which has a key value, and then you attach the amount which you want to transfer when this function gets called. All right. So the thing is that I've also used the function ether to way here. All right. Now this is not a Ethers.js function. I have created a small utility function above here, which actually converts ether to way. So the thing is that the default value type when you define it inside object is actually way. All right. So you actually need to pass the value as way and not in ether. All right. So what you want to do is that convert that ether value into way. All right. And for that, you actually have a utility function inside ethers. So you are actually going to return ethers.util. So you're actually going to use some functionality from the utils of ethers, which is going to parse the amount for you. And then you need to provide the type of that specific value that you need to get passed. So for us, it's going to be ether. So we are actually going to grab the amount in ether, and then we are going to parse it in way. And this is going to return the value in way, and then we are going to simply attach it inside the key value. And obviously every function returns a promise, so we are already catching it with .then. So once we receive a response, we actually need to wait for this response to get confirmed on the chain. So obviously it's going to perform some operations onto the blockchain, and it's going to get registered as a transaction. And a transaction always needs to get mined into a new block. And that's why we need to wait for a confirmation from the chain that whether or not this transaction has gotten mined onto a new block. All right. So we are actually going to say response.wait, and this is also a Ethers.js function with which you can actually wait for a response or for a confirmation from the actual blockchain. All right. And obviously this will also return a promise, and we also need to catch it with .then. And this will give us a receipt. All right, the receipt of the actual transaction that was performed onto the blockchain. All right, and obviously you can use it as you like. I mean, here I'm using it to set a state with which I'm refreshing my use effect. So you can use it to your heart's content. I mean, what you want to do with it. So this is actually the confirmation that the transaction was carried out, and the person actually performed the transaction and is now currently in our lottery. Now let's go on to the next function in which we are actually going to handle the winner of our lottery. All right. So for this also, we also need to create a signed contract. So we are actually going to connect a signer to a lottery contract. And then we are going to call the pick winner function. All right. And obviously we need to catch the promise. So we are catching it with .then. We are waiting for the response again. So response.wait. This will also return us a promise. So we need to catch it with .then and receive the receipt, and I am setting the state accordingly. And once this transaction is confirmed on the chain, a random winner would be picked from our player's array, and our array would get reset, and the winner would actually get all the winnings. Now I have also created another utility function that is way to ether. I mean, before we were converting ether to way, but when you call all the data from the contract that is in our use effect, it's also going to return the value in way. All right, because it's stored in way in our smart contract. So before displaying it onto a front end, we actually need to convert it back to ether. All right. So this is how you actually convert it back to ether. So you are going to write ethers.utils, and this is going to be a little bit different. So you're going to say format ether, and then you're going to pass the amount in way. And this will actually convert the amount in way to an ether string. And then you can actually go ahead and display it onto the front end as lottery pool. All right, so now that our whole application is ready to go, so it's time to see our application in action. All right, but we'll do that in the next one. And until then, keep chilling at the CodeCove.